So, hi students. First of all, I would like to thanks JNTUA Anantapuram for giving an opportunity to making online videos. So, I am K. Sayabino, working as assistant professor in Annamacharya Institute of Technology and Sciences, Autonomous Tirupati. So now I am making a video on mechanics of material subject. So this mechanics of materials is divides into two subjects. Actually, so the first two units is belongs to engineering mechanics. And the remaining three units is strength of materials. So I am going to explain the first unit concepts. So let us move to the what is meant by mechanics. So it is a branch of a science which deals under the action of forces on a body. So whether that body is in motion or whether that body is in rest condition. So we are going to study those cases. This complete study comes under in particular science, and we can say that this is an mechanics. So the body either in rest condition or either body is in motion condition. Okay, again this mechanics is divided into three categories. One is quantum mechanics, solid mechanics, and the next one fluid mechanics. This fluid mechanics is divides into mechanics of solids are divided into non-deformable bodies and deformable bodies. So in syllabus we are having this non-deformable bodies, that is statics and dynamics, and the non-deformable bodies, so theory of elasticity and theories of plasticity. This completely comes in higher educations, and we know that this is the fluid mechanics. Completely it is a different subject. So, and the next one, division of engineering mechanics. So how this engineering mechanics is divided? So see once that engineering mechanics is divided into two categories. One is statistics and dynamics. So everyone keep in mind, so here we are discussing only force. We are focusing only on force. So for example, when it comes to the statistics, so under the action of a force which is acting on body, whether it may be rest or motion condition, we can say it as a engineering mechanics. If it is strictly in rest condition, so it means, again I am repeating, under the action of a force. So under the action of a force acting on body, that body is in rest condition, then we can say it as statics. If it is rest condition, we are going to study that rest condition only, then we can say it as static condition. So for example, same thing, same definition. So but this statics and dynamics has, so it is a branch of engineering mechanics. So and under the action of a force acting on a body, whether the body is in motion condition, so that study we are going to do, then we can say it as dynamics. So if it is rest condition, it is statistics, and it is motion condition, we can say it as dynamics. Again this dynamics is divides into two categories, kinetics and kinematics. So we are completely application of forces. We are going to study completely application of forces. It means which force is acting, how much force is acting, what is the magnitude of force. So even we are studying all these parameters. This completely comes in kinetics case. So we are not focusing this what force is acting, what type of force is acting. If you are not focusing on those things, then we can say it as kinematics. So these are all different, division of engineering mechanics. Now let us move to the, so every time I am saying a force. What is meant by force? So see once here one person is applying one particular force on an object. So if a person is applying an object, so automatically this object is going to be shift to one more place. So this is a one place, and again it shifts to the one more place, and it means we are disturbing this an object. This body, for this one person is applying something on an object. This particular object is disturbing from initial to the, and it shift to one more place. This shifting is known as a force. If the body is going to be shift to one more place, then we can say that that is a force. So an agent, here agent means this person which produce or tends to destroy motion of a body, we can say it as force. And very important for force unit is Newton, and it is a vector quantity. So vector quantity means so both magnitude and direction. And the next one, what are the characteristics of force? So just now I told you magnitude, vector quantity means magnitude and direction will be there, and next one, this force either may be pull or either may be push. So in civil engineering point of view, we can say it as it's a tensile or compressive, and the application of force, either it may be point force or different actions will be there. So in detail we will study this, what are the forces are there. See, once next topic is types of forces. How many types of forces are there? So in the practical, all these forces we are observing, but what kind of force, that is we are not able to analyze. But here we are going to discuss which forces, different types of forces. So first one is contact forces. So what is meant by contact forces? So by direct contact of a body, see, once this person is contact this particular floor, and there is a force in between this floor and this person, we can say it as contact force. So this force either may be the pull type or push type. Okay, so this is the contact force. And the next one, body force. What is meant by a body force? See, once, so the force holds together the particles to form a rigid body. It means to forming a rigid body, number of particles are there in an object. So number of particles are there in an object to hold that particular body. We can get this body as a rigid. Then that force is known as body force. Here it is clearly explained. It is the force holds the together the particles forming a rigid bodies. So to forming a rigid body, one force we are going to apply on the particles. Then we can say it as a body force. And the next one, point force. In the name itself, it is a point. The force is going to apply at one particular point. See the figure here. This man is applying a force to pull up this particular nail on a wood beam. It means applying a force at one particular point, and also this force is acting only in small area. So this person is removing the nail by the action of a point force. This is the best example, and this one more example, the force is acting like this also. And next one, distributed force. This distributed force means the action of a force in large area. See, when the force is distributed over large area, we can say it as distributed force. See, once here the force is distributed a large area, but distributed force is divides into uniformly distributed is there and uniformly varying is there. So this comes in further units. Yeah, this one is also distributed force. And the next one, external and internal forces. So we are applying a, we means here the weight, self weight is an external force to the particular floor. If we are walking on particular floor, that is an. So next we will go for external and internal forces. So external force means we are traveling or we are walking on a floor. It means a self weight is walking on a particular an object, that is an external force. So due to this external force, automatically there is a development of internal, there is a disturbance in internal, then we can say it as a internal force. So just see once here, external force will be there here and the internal force will be here. Internal force means it is a stress. It means there is some resistance will be there. That thing we can say it as an internal force. The next one, action and reaction force. So this is everyone know about this action and reaction force. So what is this action and reaction force? So from the Newton's third law, for every action there is an opposite equivalent reaction. So if action will be there, automatically reaction is also there. See once, if you tie an air in a balloon and after this one remove that particular tie on object, automatically air will blows in this direction and the balloon will far away in this direction. Means both the forces are equal. And the next one, see once, if a person is traveling from boat to the bank of the river, so the action in this direction and the reaction in this direction. And the next one, frictional flow. So there is a resisting force offered during the sliding of a body by the surface in contact. See once, there is an resisting force during the sliding here. So this is the frictional force. In practically, if you apply a force on cloth while washing, so there is a development of friction. If you apply more force on a cloth, automatically it disturbs. It is not a frictional force. So if you are standing means there is a friction. The same thing here it is. So if the motion in this direction, automatically your friction is in opposite direction. This entire concept will comes in further unit. And the next one, wind force. I think everyone know about this wind force. Means force exerted by the wind. Wind only we can get this wind force. And cohesion and adhesion forces. The force developed between the molecules. If it is the same material, then we can say it as a cohesive forces. If it is different materials, then we can say it as adhesive forces. So like this. See? So if it is the same material, we can say it as a cohesive forces, and it is a different material, we can say it as a adhesive force. And the last one is hydrostatic force. It is completely force exerted by water on a body. So due to the water only we can get this particular force. Example, best example is barriers, dams or canal regulators. All are these and hydrostatic force best example. And the next one will go for the system of forces. So and the next topic is system of forces. So what is meant by a system of forces means when two or more forces are acting on a body is known as system of forces. Yeah, see once when two or more forces act on a body, then we can call as system of forces. These are all different types of system of forces. One is coplanar forces, second one is concurrent forces, and the third one is collinear forces. So you just remember these three forces definitions, and the remaining automatically you can get an idea. Okay, and these forces are very important for competitive examination also. So they will ask some definition and what is meant by this, or they are called as, and they will give some options. So these are all very important. So okay, we'll see one by one. So first of all, what is meant by coplanar forces. So coplanar forces. So already discussed what is meant by force, and it comes from coplanar means it is plane. Plane indicates here xy plane or yz plane, zx plane. All forces are acting on a same plane. We can say it as coplanar forces. The name itself, all the forces, all the line of action of forces are acting on a same plane. You just remember plane. See once the figure. So this is x, for example, if it is a y, if it is z, and if it is x, in between only one plane these three forces are acting. Okay, these are all called as coplanar forces. And the next one, concurrent forces. So you already studied in the initial stages also what is meant by concurrent force. Means all the forces are meeting at single point. Then we can say it as concurrent forces. So or otherwise all the forces are coming from one point, also concurrent forces. See once here F1, F2 and F3. All these three forces are meeting at one point. Okay, then we can say it as concurrent forces. And next one, collinear forces. It means the forces whose line of action on same line. So there is you just observe the difference between coplanar forces, collinear forces. So coplanar means line of action lie on the same plane. All forces acting on same plane, and here it is same line. You just observe the difference, same plane and same line. Same line means collinear forces. So see once, so all these three forces are acting on same direction or same line. So these two examples are known as collinear forces. And next one, coplanar concurrent forces. So coplanar means same plane, concurrent means meeting at one point. The forces whose line of action on same plane and meeting at one point. Okay, then we can say it as coplanar concurrent forces. See the best example. If you consider this is a single plane, and these three forces are meeting at one point, we can say it as coplanar concurrent forces. And the next one is non-coplanar concurrent forces. Non-coplanar means the forces which does not on same plane, but they are meeting at one point. Okay, all the forces are meeting at one point, but there is no all the forces are not in same plane. So see this. So these all forces are coming from different planes but meeting at on origin. So this is an non-coplanar concurrent forces. And the next one, coplanar non-concurrent forces. You just observe the coplanar. So coplanar means you just remember the forces are acting on same plane but they are not meeting at one point. See once, all these forces are meeting in same plane but they are not meeting at one point. Here it is also, these two forces are in same plane but they are not meeting at one point. So this is coplanar non-concurrent forces. And next one, both non-coplanar and non-concurrent forces. So the forces are not in same plane as well as not meeting at one point. Then we can say it as non-coplanar non-concurrent forces. See this figure. Each force is acting in different planes but they are not meeting at even single point also. So this is the best example. And the last one is, like parallel forces. I think everyone know about this parallel forces. All forces are acting in parallel direction. Why you add the like here means the direction of forces, that parallel direction of forces in all are in equal direction, then we can say it as like parallel forces. See the figure here, all forces are in parallel direction and also direction is also same. It means a downward direction. And next one, unlike parallel forces and quite opposite to the like parallel forces. Here all forces are acting in parallel direction, but the direction of motion is in different case. And the last one is spatial forces. The forces are acting in space. This word is very important, so that's why you can say it as spatial forces. It means, see here, the forces acting in the space are known as spatial forces. If it is meeting at one point, all the forces are meeting at one point, we can say it as spatial concurrent forces. So what is the best example means here? Parachute is the best example for spatial forces. These four forces are meeting at one point and it is acting in a space. Okay, so these are all different types of system of forces. And next we will discuss how to resolve the forces and what are the principles of mechanics. So these two concepts we will discuss in the next video. Thank you.